get started, I want to show something that I put together last night. And I put together a Burlington RubyConf treasure hunt that everyone can participate in. There is one goal to this treasure hunt. Find Brian's credit card. It could be anywhere. It could be on the floor of a bar, it could be in someone's pocket. I don't know where it is. Somewhere within this area. So,
what's your credit limit?
the hunt is on. Prize to be announced at a later date.
It seems like you could pick your own prize, you know?
Yeah, that's what
What was your birthday?
Okay, so another thing I want to discuss, I'm asking for audience participation on this, is I was going to change this talk. I emailed Pete a couple weeks ago and said, I gave this talk at RailsConf and I thought I did a good job on it. I don't want to repeat the talk, I want to give something fresh. And I thought that was true until I went back and watched my talk and the video. I have this tendency of saying, I said it 147 times in 28 minutes. So, I have this technique that I did when I lived in Washington, D.C. for a year, and my now wife, my girlfriend at the time, was in Boston. So we had a long-distance relationship, and we were using Skype to communicate. I kept saying, you know, and I'm just saying it. I'm not realizing I'm saying it, and it's driving her nuts. So every time I would say it, I would have her say, you know, just to shame me and pointing out that I'm actually saying this. So I'm asking you guys during my presentation, every time I say I want you guys to yell it back at me. So it may get really bad after a few minutes, we might drop it, but let's see how that goes. All right, good, shame me. All right. Yeah, this might be a disaster. Okay, so real-time Rails. Let's skip that. So I want another conference, Wicked Good Ruby. This is gonna be tough. So those words that you say, I looked it up. Those are called filters, and in linguistics. Damn it. It's not going to work. In linguistics, they are used to, usually in conversation with one person to another, you give a verbal cue to someone to start talking by stop talking. So in order to defend your position, you subconsciously say, so that the other person doesn't realize, so the person you're speaking to knows that you're not done talking yet and you can continue talking. However, in a presentation setting, that makes no sense. So I don't know why we still do it, but anyway, it's my problem. So maybe we can work it out together. Wicked Good Ruby conference we're running in Boston. If you guys like Ruby conferences, if you're from the area, I highly suggest you check it out. October 12th to 13th. Please check it out. Okay, so this is going to be a really bad, history of software development. A barely accurate history of software, popular software to make a point. So, a long time ago, there was a company, IBM, and IBM owned the landscape of technology. They created all the hardware. They had a monopoly on everything. And a little guy came along, Microsoft. Microsoft said, hey, IBM, you guys are selling the hardware. How about we come along and sell the software? And IBM was like, oh, that's crazy. No one's ever going to want to buy software. So Microsoft went ahead and did that, and they did very well for themselves. And Microsoft was selling all the software, and this other competitor came along, Sun Microsystems, and they said, hey, you guys are selling the software, how about we just give it away? And we're going to create a language called Java. It's going to run on every other system. Microsoft's like, that's not a really good idea, but you guys go ahead and do it anyway. So Java did very well, and the guy in the middle of the Java developer was Cooper. Sorry, Java devs, if you're in here. So the Java was competing and winning in a lot of space enterprise areas. So Rails came along, and Rails like, hey, we're going to run a scripting language on a server. And we're going to take a lot of the concepts that you guys are doing right now, and we have a different way of doing things. So Java's like, that's crazy. We're not going to do that. Go ahead. And Rails proved itself. it became a force to be reckoned with. And those are rock stars and ninjas and all those playing terms. Now finally, Rails has matured quite a bit over the past few years, and you've seen, you may have seen posts recently in the past year that Rails is no longer cool. And there's some truth in that. A lot of it comes from that the cool things are the ones that are always challenging the boundaries, saying, oh, there's new technology, we're going to push in that direction. Rails really hasn't done that in the past few years. It's really been more of, let's refine what we have and really focus on that, starting with the merge in 3.0. There's been some nice things that came out of it, but no like major different ways of thinking about how to build applications. A competing framework that came out a few years ago, Node, said, okay, we're going to do things very differently. We're going to run JavaScript on the server. And we were all like, okay, that doesn't make any sense whatsoever. But go ahead, it's fine. And Node has done very well for itself over the past few years. As if stars on GitHub mean anything. So, what is that? I stopped saying damn it. So what's the point? Well, one aspect of where Node has really eaten our lunch is in allowing you to create real-time applications on the browser. So that's one place that I think there is a lot of ground that Rails can still make up. And what I'm going to talk about today is how we're not really that far away from it. Even though the basic way Rails works kind of is completely opposite from long-lasting, persistent connections, there's a lot of groundwork that's been done over the past year or so that kind of we're not too far away from having this really nice framework for real-time in Rails. So for a long time, Rails, they innovated with really pushing MVC on the framework side. They innovated with the RESTful frameworks. They innovated with, I guess now with the asset pipeline. I don't know if some people see that as an innovation, but I really want to see Rails kick ass in this department over the next few years. I think it comes down to whether or not some people on the core team decide whether that is a priority for them. But I think what we can do as a community, if people are interested in this technology and create tools around it, prove it out. So can Rails scale its features? Before we get into WebSockets and server-side events and all that stuff, I want to just lay the groundwork for a primer on socket-based programming and concurrency-based programming. I think that a lot of Rails devs, even though they've been doing Rails for many years, we are shielded from this type of development. A lot of people that consider themselves to be advanced Rails developers probably have not touched sockets or done much asynchronous programming outside of JavaScript. So beyond what I'm going to, that looks all weird, T's and P's. I guess that's still right. Yeah, so beyond my short few slides on this, if you want a more in-depth explanation, definitely get this book right here. It is awesome. Jesse Storumer, I think is pronounced. Working with TCP sockets. He has a few other books, I think 2 other ones. Those are also great. They're not too much money. I think they're like 10 or 15 bucks. Definitely grab those and read them. I think each one's about 100 pages too. So, the transportation of data from your browser to your server and from your server to your browser over TCP. This is how it works. Your data gets broken down into frames. Those frames are broken down into packets. These packets travel through the internet from the sender to the receiver. The receiver then constructs the packets back into frames, and the data is extracted out of the frames. This is important. We're going to see this stuff later on when we're working with like some raw, low-level WebSocket stuff. Concurrency is going to be a big barrier, I think, a lot of Ruby developers, Rails developers, people used to working in a single-threaded process, people used to just this normal, non-asynchronous way of thinking, having to get over. And some of the things I'll be talking about are, I'll touch on in a moment, concurrent web servers that we can use, working with threads in Ruby, pub sub, and thread safety. So the web servers that are concurrent, you can't use Unicorn. Unicorn is not a web server that's going to work for this. However, there are a few options here. Puma, Rainbow's thin, and I think the latest version of Passenger Fusion is also now fully concurrent, but I don't know about that. I think I heard that somewhere. But I like Puma. Puma's my favorite out of all these. The reason is, I think we got someone coming here.
Our packets are here.
Yeah, great. So, the reason why I like Puma is that it's the most memory efficient one out there. Instead of forking the processes that all the other web servers do, it will actually just use threading to allow for concurrency. So forking will actually create a memory copy, whereas threading just saying we have this process already running, we're just going to throw some additional threads out at it. This is a quote from Nick Gauthier. I'll be showing a library that he wrote in a bit. But Rails 4 is now fully concurrent. There is no full stack lock on a request. If you use a concurrent server like Puma, you can handle many requests at a time with a single process. This is really, really important, and the reason why this stuff is not possible until Rails 4. It came from, I believe, a lot of the work that Aaron Patterson did on the Action Controller Live module, which we'll be showing soon. Now with threads in Ruby, you have access to a thread class, and they're pretty easy to use. You just create a new instance of the thread, you throw your code into the block, and it's up to you how long you want to keep that thread alive. Some things you're going to have to be aware of, though, is the downside to using threads. You have to be aware of deadlocks, and you're going to have to be aware of race conditions. So this is a very simple, overly simple example of the syntax for a thread. It's not super interesting. We'll go to a more interesting example right here. And this is an example from a client application that we wrote. Similar to a chat roulette, where you have several virtual rooms. Each room can only hold 2 visitors. Visitors are assigned to a room as they join, and when a room fills up, the next joining visitor is assigned to the next available room. So I want to demonstrate where this can be a nasty race condition and a solution that we can have for it. So I'm going to ask for some audience participation. I want to get these guys up. Come on. Maybe one more.
Sweat crew.
Yeah, okay. So, are we good over here? Okay. So, you guys are going to be incoming requests on a server, and the code you're going to run in your head is, imagine that right around there is the room you're going to be joining. Only 2 people can be in that room at a time. So, when you come in as a request, you're going to say, how many people in that room, count them, and if there are less than 2, then I join it. If not, I'm going to join the next available room. So let's do it one at a time. Let's imagine that these requests are coming in fairly spread out. So you're going there, now you're going, and then you guys, so there's 2 in that room, so now you're going to be over in the room next to it, same right there. So that's nice if people are coming spread out. But what if your application gets, I don't know, on the top of Hacker News or TechCrunch or whatever? Let's move that. All of you guys go at the same time. All right, they all try to go at the same time. So what we can do is we can put a choke point on our application, and we can accomplish this with a queue. So when the request comes in, they may all come in relatively at the same time, but with an asynchronous application, you may have someone saying, checking the condition of the number in the room, and before they do the action of joining the room, someone else has already come in and they're running that same conditional right after you run the condition, prior to actually joining the room. So that's an example of race condition where it's true for the second person, but when they go to join, there may be 3 people in the room at that point in time.
Awkward.
So, what's that?
Awkward.
Yes, it's awkward. So let's put in a queue where now you guys are all joining relatively at the same time, but now you have this choke point where you're going to be processed one at a time. So all you guys kind of join. Oh, now you're in queue. You all line up right behind one another like a queue. Vertically like that. Yeah, come in, come in, come in, come in. Okay, so now we're going to just process you one at a time. You, room. It's we're the same deal. We're queuing. Okay, so now they were processed one at a time, individually, and this is one strategy for dealing with asynchronous code. So, okay, guys, thank you very much. So in Ruby, you have a mutex class, and there's a synchronized method on the mutex instance that gives you access to a, what's that? Oh, thanks. Gives you access to a queue that you can use within the runtime of your Ruby application. So if you create a new global variable, mutex new, and then inside the synchronized block, anything that you put in there is going to be run in order. So even if you have code that's occurring across different threads, it will be processed as one. You could also use external lists like a Redis list if you have an external service. You could use the external job, an external worker if you want. PubSub. So for those that are not familiar with PubSub, it stands for publication subscription. This is going to be a really useful tool for you to use in an asynchronous application. The more popular ones are the Redis PubSub and ZeroMQ. I like the Redis PubSub. I wanted to mention that Postgres actually has PubSub functionality. It's known as Notify Listen. I like talking about Postgres because it's awesome. So in Rails, prior to Rails 4, there was really no way to do any of this asynchronous stuff. So if you wanted to have a WebSocket server, you'd have to run an external Node server, or in the case of what I've done before, is an EventMachine server. Or I guess Celluloid is the new hotness in that world. There are external services for PubSub, Pusher, and Fay. And the idea of PubSub is simple enough that they could just, it's not really too difficult to extract out as an external service, but now we can put everything into one application. If you are doing a simple real-ish time application that, similar to like a campfire room, you might not need real pushed events, and this is probably something that you've done before, because to the client, it's indistinguishable. It feels like it's real time. If someone types a message, I receive it within a second. So it's called long polling, where we have an asynchronous request, and we just get the, we send the last time that we made the request, we get the delta of the data, and then we set a timeout, and we re-poll again at the end of the timeout. Now, in Rails 4, we have a module that you can include into your controllers called Action Controller Live. Action Controller Live is a proxy object for the socket, and it's going to give you a streaming response object that you can write to and read from, similar to any other I/O object. Example of bringing this in, this is maybe your long polling response endpoint. This might be an example, that's some weird highlighting. This might be an example of Action Controller Live response, where you're going to just put it into a thread, and you're going to you have access, your regular response object up there now has this stream object hanging off of it, and you can write directly to it. So there's Aaron Patterson has a blog post explaining all this, and he wrote the proxy object to quack like an I/O object. So it's very similar to like a file object or any other I/O object in Rails. And here's a very simple example of doing just that. So we can call the write, the close, and the read methods on that. And another example from his blog post, we're using server-sent events. I haven't used server-sent events outside of this demo here, but you can think of them as like a ticker that's constantly being sent or streamed to your browser. They are a very simple format made up of just key value pairs, and each value in the set is delimited by a new line, and then each event itself is delimited by 2 new lines. So in this example, we're setting the content type so that the browser realizes that the response is correct, and then we can name the event. We can give it an event name of time, because on the browser side, we can subscribe to specific, let's see it down here, highlight this. We can subscribe to specific events. We can also attach an ID to the server-sent event. In the case that someone disconnects from the browser from the server, they have the ID, and the server can hold on to the ID, and the next time they reconnect, they can pick up where they left off. Example that I put together was, let's try refreshing this. So Here we just have a server that's sending the current time of the server, and it's going to go for 5 seconds, and we can see down here that this process went for around 5 seconds, and then it pauses, and then it picks up again. Again, I don't really have a lot of use cases for this. I guess if you're doing like a sports ticker or something like that, that might be interesting, but that one wasn't for me. So the proxy object that Aaron Patterson wrote is good, but in his blog post, he admits that he had to write around rack. It got in the way for what he was doing. Fortunately, back in January, I believe, rack 1.5 came out. With rack 1.5, there's a new object in rack called rack hijack. Rack hijack will allow you to actually hijack the raw TCP socket out of your rack request and get access to it and write to it and read to it just like a regular flow, because it is a regular socket. Your app server, rather your web server, whether it's Puma or something else, will inject this rack.hijack question mark value into the rack environment variable. And if it responds with true, then your web server supports rack hijack, is concurrent. In order to get access to the socket, you do rack.hijack, no question mark, and call on it, respond, it'll give you the TCP socket. If you need that socket again later, you can get it back, the same one with rack hijack _IO. There are two forms of using rack hijack, full hijack and partial. Today I'm just going to be talking about the full hijack. And here's a common pattern that you'll probably come up with if you get into this stuff. You make a request to the server, the TCP socket is hijacked, you put that socket into a thread to keep it alive, and you need to complete the rack request. And you do that by just responding and rendering out a 200 with an empty body. The thread, meanwhile, is still kept alive if you have it in a long-running loop. And then the web server, depending upon which web server it is, will decide whether or not it will allocate a new socket or if there's just a given pool of TCP sockets that are available, and then it will eventually run out. And so when you're done with the socket, you have to close it properly so that it goes back into the pool. If anyone's interested in reading more about the rack hijack spec, it is in this spec file on the rack project. It's, I think it's about halfway through. If you just search the file for hijack, there's some good documentation in there. So WebSockets. I find WebSockets to be far more interesting, whereas service intervents is purely a one-way communication from the server to the client. WebSockets allow a two-way communication. So the server can push data to you, and you can send data to the server without either side requesting it in the first place. And I was not able to get WebSockets working with the proxy streaming live object that Aaron Patterson did. I was able to get them working with rack hijack because it's just the raw TCP socket. And there is a WebSocket gem out there. This one, WebSocket-Ruby. And I have this, the code I'm going to be showing has a branch of using the master branch on GitHub. I don't know, there was a change made, I'll show in a moment, that allows you to pull in the rack environment into the WebSocket headers instead of writing them yourself. And I don't know if that was released yet or if it's still sitting on master. If for whatever reason you think that your WebSockets are not fast enough, this WebSocket-native gem is all compiled down to C. So here is some example code, and this is where the frames and data stuff that we talked about earlier comes in. On the first block up here, we are grabbing the rack hijack socket. And then we are creating a WebSocket server with this handshake object. And then this here, this from rack method, is the one that is available on master of the WebSocket gem. So we just pass it the rack environment variable, and it will set up the, all the headers for us. And then we have to write the handshake back to the socket. And this is after the client makes a request to the server. Now when we're reading data out, imagine we have a while true loop or a while 100 loop, however long we're just continuously spinning. We are pulling data from a frame. So we create a new frame, and then we read raw data from the socket. And here I'm pulling out the first 2,000 bytes. And now we push that raw data into the frame that I created, and then we iterate over the frames and we can pull out the actual data that was sent over. It's somewhat similar to writing out back to the client. We create a new frame to send out, and we just add the data in as a message here, and then we can write to the socket, and we force it to a string. I believe that there was another WebSocket gem that was released a month or two ago that cleans up some of this quite a bit, but I'm going to be showing another library that actually removes a lot of this stuff from you, but I want to at least show this. So again, just to reiterate, we're constructing the header, we write the header to the socket, we write data to the socket, we read data from the socket, and we close the socket when we're done. We should always be closing the socket when we're done. On the client, if you have never worked with WebSockets before in JavaScript, it's significantly cleaner API. We just create a WebSocket, point it at the remote server, and then we subscribe to certain events on that object. So I have two demos I'm going to show. This is all running from the same Rails application. It's live. If you go to btvruby2013.com, we can go into a chat app, and then I can say hello. If anyone else has a computer, they can join up and they can start chatting. And likewise, there's a drawing application where other people can join and draw stupid little figures on there. So this is all the same Rails application. These aren't separate Node apps that are running. These aren't EventMachine applications that are running. Actually, I'll show, there we go, so people are joining up now. So we can see that, I think that it will go up to around like 30 or 40 people joining at the same time before this memory leak occurs and it just kind of shits out. But, let's see what's on the chat side. So people are chatting in there. Oh, no one's tried to do any JavaScript injection yet. That's good. No, I'm using Ember, so it protects me from all that. Oh. All right, let's go back here. So what you'll notice is after you're creating a bunch of these applications, a similar pattern seems to occur. Your client is capturing events from the server, and they're sending data back to the server. Data gets normalized in some way, and then the event data is broadcast to all the connections, and that's where PubSub comes into play. You can think PubSub as like I don't know what a good analogy would be, maybe a TV channel where everyone's watching that channel, and that channel now just sends data to all the watchers at the same time. So if you have multiple rooms, you're going to subscribe to a different channel, and so when one person in that room or in that channel sends data to that channel, it will now send a on-message event, to everyone that is subscribed to that channel. So you can use that event as the opportunity to kick off writing data out to the socket back to the client. TubeSock. TubeSock is written by Nick Gauthier, and this cleans up a lot of that other code that I showed you a lot. So it's for Rails 4, Rack Hijack, and WebSockets. And inside your action controller method, you run this hijack block. It will do all the low-level stuff that I wrote out earlier. Then the API is pretty similar to the WebSocket API on the browser. You get this TubeSock object, and then you can just subscribe to certain events. This cleans up a lot. So some of the challenges that exist still with WebSockets is, to my knowledge, Heroku does not support it, and I think most people probably put their at least toy applications to play around with on Heroku. It kind of goes against what Heroku's business model is. They're always pulling servers down and bringing them back up, and there's inactivity, and with long persistent connections, that doesn't make sense. But I think it would be nice if Heroku, if you're paying for a server, that they would at least allow you to use WebSockets. And Nginx seems to have, if you get it configured right, it's fine with WebSockets, but it's a little tricky. They will by default have a 60-second timeout for any inactivity. So if you're in a chat room and no one's talking, you'll just time out, you'll disconnect you. You can bump that time up to 24 days, but it would be nice if it had like an infinite connection. If you're doing server-sent events, you might have an application that you're building that's just constantly sending out data. You don't want to reset it every 24 days. And in the future, whereas the action controller live stuff is one way of getting this raw socket and streaming data back to the user, and now we have this new and better way with Rack Hijack, I'd like to see in Rails 4.1 an effort to possibly combine the two, or just replace action controller live with an API that wraps Rack Hijack. I'm hoping with the action controller live stuff, that's an indicator that Rails is moving towards this real-time, at least having better support for real-time for the client. With frameworks like Ember.js and AngularJS coming out, I think that having this type of support on the server is going to become more and more important. And that's it for me. Thank you guys very much.